Hello everyone. So today I'm going to talk about the Hardy hierarchy. So it's basically like a kind of like sequence of numbers that use ordinals that you can create very large numbers. So let me start with a few definitions. So firstly, h sub 0 of n equals n, and then on the second row, h alpha plus 1 of n equals h sub alpha of n plus 1 here. So h sub alpha of n equals h sub alpha, the nth fundamental sequence of alpha of n. So this is like the symbol here as shown, where a square bracket n is the nth fundamental sequence of the ordinal alpha. So if you try to do it with omega, which is the first number larger than all the natural numbers, if you do n, that's just equals to n. So let me just give you some examples. So at the start it grows really slowly, so h sub 0 of n is just n, and then if you put a 1 you just add 1, and then if you put an some number m here, you just do n plus m. And then when you put omega, then the omega get replaced by n, then it's just h sub n of n, which is just n plus n, which is just 2 times n. And then again you can continue to add 1. So after what you add 1, you just h omega of n plus 1, which is 2 times the quantity n plus 1. And then if you try to add an m here, it's just 2 times quantity n plus m. And then when you continue, you will reach omega times 2, which omega times 2 is just omega plus omega, shown here. And then we have, and then one of the omega will be replaced by n. You never replace both of them, you just put it at last omega, then you just do the thing as we have done above, and that is just equals to 2 times 2 n plus n, which is just 2 times 2n, which is just 4n, as shown here. Now what gets interesting, when you put omega times a here, you can see that each time I add omega here, it will just be multiplied by 2. So h sub omega times a plus b of n, it will just be 2 to the power a times the quantity b plus n. Still not growing really fast, just pretty normal exponential functions. So we continue to omega squared, then you just do it as like omega squared is just omega times omega, so you do it this way, and then you just get h sub omega times n of n, which is just 2 to the power n times n. So now here you can continue h sub omega squared plus 1 of n, that's equals to 2 to the power n plus 1 times the quantity n plus 1, as from the rule above. So here's n, and then when you add plus 1, you just put the plus 1 here. Yes, and then if it is omega squared plus 2, then you just do 2 to the power n plus 2 is n plus 2 instead of n plus 1, and then here as well n plus 2 instead of n plus 1. So as we continue, you can just do something like omega squared plus omega times a plus b, which is just 2 to the power 2 to the power a. And then you see that, it's like stacking exponential function. So actually it's like starting to grow really quickly, this function. So 2 to the power 8 times quantity b plus n, and then you multiply by another term, 2 to the power 8 times b plus n. And then if you do omega squared plus omega times a plus b, that's like, it's like growing much quicker. So you just, because I realize like it's like that. Like when you do just omega squared, you just do here, 2 to the power, and then this n is like do this, 2 to the power n times n, and then times n like this. So if you try to like to the power a and then times b plus n, just do it like this, and then you get this thing, this monstrosity here, which is like larger than 2 to the power 2 to the power 2 to the power a. And then like we can continue this on part 2, and then we will reach like omega cubed, and it's like the function is just going to grow very quickly, like this omega cube, and then omega to the 4, and then omega to the 5, which, and then even omega to the omega, which I will talk about in part 2. So here is the end of my part 1. Remember to subscribe, like, and comment down below. And if you know about this, you can just share to me a bit about your knowledge on these in the comments below. Thanks for watching. Bye.